Our next speaker is a software engineer. He's Malaysian and he's working at ETHKL Labs. His name is Sun Hao Ye. Let's put our hands together and welcome him to the stage. All right, Hao Ye, the stage is yours. Take it away. Thank you.
All right, thank you so much. Thanks everyone for taking your time to attend this talk. Hope everyone is still awake. This is certainly not the best time slot for a talk. Maybe because I didn't pay for my tickets. Okay, so earlier today, we've heard many people talk about very exciting stuff on the future of DeFi, right? What the future holds for us. But today, or right now, I'm going to take a step back and talk about what's happening in the present. Okay, some of the nuances, and you will basically hear me rant for the next 30 minutes. Wait. Okay. So a quick intro about myself. My name is Hao Ye. I am a senior software engineer at ETHKL Labs. So what ETHKL Labs does, we are primarily focused on market making, on MEV searching, path finding for intent-based swaps, as well as block building. We also have many more exciting projects down the pipeline that's brewing. So I want to start with a hypothetical case, right? So imagine you have a trader friend who comes to you and say that, hey, I have found a strategy that can give you consistently 10,000% in returns, and I've backtested it. Can you help me to write a bot to implement it? And you as a dev, you answers to the call. And so what is the strategy? Simple. Instead of being the 100x trader, we have found a 100x trader, and we decide to copy all his trades. So what kind of trades is this person making? Specifically, it involves meme coins. We're not even talking about PayPay here. We're talking about Harry Potter, Obama, Sonic, Inu here. This is the real deal, your 100x coin. And so in order to monitor the trades being made from that address, you need a way to monitor transactions in the blockchain, right? And how do you go about it? What do you look out for? First of all, very basic, you need to look at where is it sending from, who is it sending to. You do filtering over there. And by looking at the recipient address, you can probably guess that which contract is it being sent to. If it's using some generic Uniswap router contract to execute a swap, then you can pretty much decode what are the parameters being sent to, and you can know what's being traded. A better approach would be to look at the logs. So if it's a Uniswap-based pool and all of its forks, it's going to emit this event, this swap event here, and there are some pretty useful info that you can get from there, like what's the amount, what's the pool address, and sorts. But at times, these sophisticated traders, they don't use the Uniswap router contract directly. They write their own smart contracts to do the routing for them. And as such, it's hard to decode and figure out what's going on in a transaction. And so in this case, you have to rely on internal transactions as your best buddy. So essentially, this happens when a smart contract calls another smart contract's function, and then it involves some funds transfer. So these things are captured in internal transactions. So on EtherScan, it's on this tab here. And so where do you monitor? So there's only two places, right? One is the public mempool, and one are confirmed transactions. So if you look at transactions that are mined or confirmed, this takes the least amount of effort, the least risk. But if you're trying to be the fastest, you're trying to send your order as fast as possible, this might not be ideal for you because all your actions are at least one block slower than the previous trade. You only know after the matter of fact. And a better approach would be to look at pending transactions, or some people call it mempool transactions. So as such, if you see the transaction in mempool, you can immediately send your order and expect that your transaction happens in the same block as the transaction that you are spying on. But the problem is the person sending the transaction that you want to follow might not end up in the public mempool because they can send what's called a private transaction that does not go through this path. And if you were to just look at pending transactions, you wouldn't see anything there. And also, because these transactions are pending, they're not confirmed, they may actually revert when it's actually being executed. So it carries a bit of risk there if you try to follow that. And so how do you monitor these transactions? There are a couple of ways. You can start with using Web3 APIs. So your regular node providers has a WebSockets endpoint for you to subscribe to, where you can subscribe to all transactions that's going on. But they only give you the transaction hash, and then for each of them, you have to fetch the data and then do your own filtering, your own decoding. So it's a lot of work there. And the problem is you cannot see internal transactions from there. It's not part of the standard Web3 API. It's not exposed there. It's actually one layer down at the Ethereum node client. And if you want to get that information, you're going to have to pay a bit of money. So there are these companies, like just to name a few, BlocksRoute, BlocksNative, Alchemy has them, Nansen. You're going to have to pay money to them to subscribe to also a WebSockets endpoint, and you get a lot more information, and it's much easier to work with. So you just tell them, tell the endpoint or the service provider what address you want to monitor, what address you want to spy on, and then as soon as it detects anything related to that address, it's going to send you all the information you need, including internal transactions. It also results in higher performance as a result. But if this doesn't satisfy you, or maybe the service provider has terrible service, like sometimes it doesn't work, or it just misses out something, or the latency is too high for you, you might want to try you might want to try to run your own Ethereum node with some custom logic on top of it. As such, you have more control. You can do pretty much everything there. Everything you need to see is already there. If done correctly, it can give you higher performance, but at the same time, it results in more effort and cost from your side, because running a node requires a pretty high performance machine to do it, and also you need someone to maintain it. So purely due to economies of scale, you might be better off using paid services for most people. Okay, so we go one layer up to our strategy. Some people might say that it's not even a strategy, right? You're just copy trading. But there are things to consider. So first thing to consider is, are you even able to execute a trade? So there are many avenues that the trader can send a trade to, like different DEXs. And if it happens that that DEX is not supported by you, you didn't integrate it, so you cannot follow that trade. How much to trade? If the trader is trading like 10 ETH, you only have 5 ETH in your capital, then you got to decide on a number. Another concern is low liquidity pools. So these pools are considered a very high risk, because any kind of trade with a small amount results in a very large price movement. So this gives a lot of problems when you're trying to calculate your unrealized profit and loss, as you cannot get an accurate picture of what will be the actual price that you can execute if you decide to close the trade. Also, you need to do some risk management. So in the context of meme coins, there are quite a lot of risks involved. I will bring up some very common and funny examples. First one is token tax. So if anyone has traded meme coins, you probably know that these tokens carry a tax. And basically, when you buy and sell, they will take a cut from you. But how much do they take? You have to find that out. Right? And it can be different. A lot of times, there's 0% buy tax, but a 30% sell tax. So they want to get you in. Okay. And this is even more nuanced because some of these contracts have the ability to update the tax at any time. So yeah, if you're trying to calculate, again, you're trying to calculate your unrealized profit and loss, right? You don't know the tax, then how are you going to calculate? Also, we've seen certain tokens that carry taxes that change according to time. Like, for example, the longer you hodl, the lower the tax, but the longer you hold, the more exposure you get. Yeah, so. Yeah, there are a lot more gimmicks out there. So the other one is bot detection and also some whitelisting measures. So basically what they're trying to do is they're trying to filter out bots. So if they detect like you're sending the transaction from this address, but the recipient of the token goes to another place, yeah, sometimes they consider that as a bot, or they might have a list of addresses that they maintain somewhere. And before they actually transfer the token, they will check if that address is in their whitelist. So they just want to let their close group of people trade that token. And they only do it when you try to sell. They don't check when you're trying to buy. The third one is outright scam tokens. You can say that meme tokens are a scam altogether, but these are the scams of the scams. Okay. So it's also called a honeypot token. Essentially, you can only buy, you cannot sell. When you try to sell, it will throw some weird error that doesn't make sense. Yeah. And more interesting one is a sell tax of 100%. Yeah. So when you try to sell, you end up with nothing. Some have 99%. Yeah, a little better. Okay, thanks. Fourth one, very common, rug pulls. So yeah, the first method is a token dump. Essentially, the token creator has a large stash of the token, and when the time is ripe, he just dumps all that token in the pool and extracts out the liquidity of the other side of the pair. The second one is called a liquidity rug, whereby the owner supplies almost all of the liquidity in the pool, and when the time is ripe, he just removes all of them. And then no one can trade from there anymore, unless you want to supply liquidity there. Okay, so we've come to order execution, and there are a couple of things that you need to take care of when you're sending your transactions. The first one is transaction simulation. So it might be a good idea to simulate your transactions before sending them on-chain. And how do you do it? It's not part of the Web3 APIs. It's actually a private service that's provided by these different providers here. Tenderly, Alchemy, BlockNative, RPC Fast, just to name a few. And what these services provide you with is that you can send an unsigned transaction to an endpoint that they provide, and then they will help you to simulate your transaction against not only the latest block, but also against all the transactions that's pending in the mempool. And as a result, you get much more accurate gas estimation. You can also have a very high probability of a guess of whether your transaction meets your outcomes. You also, if the transaction happens to fail in simulation, then you can avoid sending it, maybe change some parameters, for example, setting a higher slippage before sending it so as to avoid wasting gas on reverting. But the issue is not all chains are supported. So if you're only on Ethereum mainnet, it's generally okay. But I think For Tenderly, they support a lot more chains, but the rest, it's pretty much very limited. And also, there's this issue of unpredictable latency. So sometimes it takes like below 100 milliseconds. Sometimes it takes like a second for the results to come back. So that's going to affect your overall system performance. And then after you have simulated a transaction, you have a very high confidence of sending it on-chain. What you do, basically, you call the send transaction function, right? You send it to a mempool, and then one of the block builders, or if not all the block builders, pick your transaction. The block with the highest value gets picked up by a validator, and it goes on-chain, right? Yep, but that's not the case, because if you don't set your slippage correctly, you're going to encounter MEV searches. And what they're going to do is that they're going to apply what's called a sandwich attack on your transaction, whereby they take your transaction from the mempool, slot in one transaction before and right after a transaction, and send what's called a bundle transaction to the block builder directly with a very high priority gas fee, which you can think of as bribe to the block builder. And as such, the block builder is incentivized to take that bundle instead of take your transaction directly from the mempool to be included in the block. And yep, that results in the person sending in the order executing at the worst price. And then the profits go to the MEV searcher and the block builders and validators. Yep. So how do you prevent that? You can send a private transaction or a bundle transaction by yourself as well. So you're gonna have to send it to the block builders directly and hope they include it. But usually it's okay if you're on Ethereum mainnet, because probably some of you know that on Ethereum mainnet right now, 5 block builders dominate like 80 or 90%. They create 80 or 90% of the blocks. So you just have to send your transaction to 5 of these block builders. It's very likely that your transaction can go through. But from experience on other chains, like if you're on BSC, it's not that simple. Like the success rate of private transactions are much lower there. And for bundles, it's even worse. Yep, so I'm just gonna give a quick run through of how this sandwich attack looks like. If you go to ETHKL, you see something like that, right? It's not immediately obvious. Like you see this person, Jared from Sunway, is a very famous MEV searcher, very profitable guy or team. So you see like 2 transactions, and then in the middle can be 1 or more transactions. And if you go in and decode what's going on and it involves the same pair of tokens, it's very likely it's a sandwich attack. And there's a very useful website called ETHKL. You just paste the first transaction's hash there. It can actually show you, it can link up the other transactions and show you what's going on. So you can see that this is the original transaction. So victim is the one in the middle. And then what Jared has done is front run and back run your transaction, which just means putting a transaction before and after so as to affect the swap price. And lastly, I'm gonna just go through quickly on the blockchain itself. How do you talk to it? It's very simple, right? You just use a Web3 API and job's done, right? But if performance is an issue to you, this is the first place that you should try to optimize, which is your networking. And from experience, if you use Alchemy's RPC node, right, and your server is in Southeast Asia, you're gonna have horrible performance. And by just spinning up your server in US instead of Southeast Asia, your latency can improve like 10 times. Yeah. And if you happen to be using QuickNode, Asia is okay. Yeah. So these are some of the useful tools that I use and also shown in the previous slides. For analytics, you can use Dune, DeFi Llama, And to analyze tokens, whether it's a scam or not, what's the tax like, there's DEX tools, DEX analyzer, EtherScan, definitely. Tenderly, very good for simulation as well as for debugging. They have very rich debug info provided there in a very nice UI, and it's free. DEX Screener to basically look at what's the most trending meme coins and look at charts. EigenFi, very good for arbitrage and MEV related stuff. They have a very comprehensive analysis there and very useful statistics there as well. So some key takeaways that I hope you guys get from this talk is that you understand some of the basic components when it comes to DeFi trading, not trading in general, but things that are specific in DeFi that goes on-chain, and some of the considerations when building them, challenges at different stages, some popular tools that you can use, and lastly, it's an exciting field. There's always something to learn and always new problems to solve. And with that, I'd like to conclude the presentation. Yeah, thank you all for your attention. If you'd like to discuss more, please hit us up in our website, email, LinkedIn, and we are still hiring. Thank you.
Awesome. Thank you very much. Let's give him another round of applause. Thank you, Hao from Toka Labs. They are still hiring, but all positions are in Singapore, right?
Yeah.
Yes. Right. Okay. So anybody want to earn Singapore dollar? Well, you know where to go. All right. Anybody want to raise their hand for a quick question? You can ask him any questions you have about the DeFi trading strategies that he's mentioned. Just raise your hand. We'll pass a microphone to you. I wanted to ask something. Have you ever done a sandwich attack to other people?
Oh, no.
Oh,
I don't do that sort of
very
thing,
good boy.
I'm
okay.
an ethical person.
Sure. You tell me later how you did it. Anyway, is the only way to prevent a sandwich attack by doing, you mentioned two things, private or bundle? Are those the only two ways?
No, actually, you can also set your slippage requirements to be really tight, such that there's really not much that you can move.
So a sandwich attack can only happen if your slippage is big enough.
Usually, yeah. But by setting your slippage to a very tight value, your transaction is very likely to revert due to pure trading activity.
I see.
Yeah.
Okay. Or just use a centralized exchange. Anyway,
don't listen to him.
Yeah, feel free to raise your hand. Anybody got a question about DeFi trading strategies? We got one in the front here. We'll pass a microphone to you. Just introduce your name, please, sir, and the question you have.
Hi, my name is Steve. Earlier you showed about the MEV searches, right? The bots. How do they make money?
Okay, I think this itself is a big topic, but I'll just go specific to the sandwich itself. Yep. So if y'all don't know, the AMM model, how they price a token is based on the liquidity that's available in both pairs. So if they want to sandwich your order, what they can do is that let's say you're buying a token, and then they submit a buy order before you with a large amount such that it moves the price up. And as such, if your slippage allowance is okay, it passes through, your trade will get executed at that very high price. And then how they earn money is that by inserting a transaction right after your order, because the price is already jacked up and you've bought at a high price, and then they will sell the token at a high price. So they earn like a delta from there. So yeah, that's a general idea to think about it. Yeah.
Okay, you can probably have a masterclass on MEV bot execution strategies next time. I'm actually quite curious to learn. I know it's quite an interesting topic as well. Anyone else want to ask another question about DeFi, trading strategies, challenges, implementations, going once, going twice, gone? All right, let's give another big round of applause. Thank you very much. Really appreciate your time. You can just leave your mic on the table here. Thank you so much.